Good evening and most welcome to a shorter nightly lecture, about half an hour and some discussion. I will continue with a very condensed, precise and accurate description in the article Cat, Retrocausality and Emotion of Alan M. Rehn. And I will continue where I left off in 1387. And I am presently no numbers on the pages. Well, I'm in page 3 and we are going to put a link to the paper in the description so you can follow. This is the 4th paragraph on the 4th page. The group velocity, no sorry, 3rd page it is. The group velocity is the one with which an object, e.g. particle, is moving. Matter normally not able to move faster than light. Although relativity does not exclude the possibility of particles, tachyons, moving at superluminal speed. This has not been observed. Consequently, at least for all normal matter, the group velocity is less than c. Little footnote here, c is the speed of light, a constant in Einsteinian relativity. Thus, the phase velocity normally has to be larger than c. As the group velocity tends towards 0, the phase velocity tends towards infinity. Consequently, for a stationary wave packet, the phase velocity is infinite. This means that an orbital is spanned instantaneously, and thus the electron is everywhere at all times, corresponding to infinite speed. Very important. This means that an orbital is spanned instantaneously, and thus the electron is everywhere at all times, corresponding to infinite speed. Two things: everywhere and at all times. Not a limited number of times or a limited number of places, but infinity. And at each location it has to build the entire field of photons and vacuum polarization. A second theorem by Feynman states that the evolution of the wave function is identical to the result from all possible trajectories connecting the initial and final state. This view supports the idea that the tiny electron moves at superluminal speed or equivalent between different parts of the wave function. One obvious possibility would be that time does not proceed in any specific direction between observations. This is a reversal and a parallel to the Morrison-Morley experiment of 1887. The constant speed of light make time go the same in all directions. This view is supported by the shape of the wave equation. In the non-relativistic case, the Schrödinger equation may be used. Generally, time is considered to be topologically one-dimensional. Assuming time to be complex valued, an interesting property emerges if the Schrödinger equation is written in imaginary time, then it would look like, and you can check the equation number 2, which is oddly enough formally identical to the diffusion equation. The diffusion equation is the one that rules how, for instance, the particles in a gas spread evenly in a container directly. Concentration changes in a solution result from random movements. And chemical reactions among molecules. Similarly, development of the wave function can be looked upon as a result of random movements of particles in negative imaginary time. Actually, the movement of two particles, one giving psi, the other its complex conjugate, psi asterisk or psi star. Such random motions would give rise to the wave function being spanned by particles following all Feynman's trajectories. But it requires influences outside the light cone or some other strange behavior. I'll go to the paragraph on page, count the pages. Page 6, first paragraph. Choice among Q quantum mechanical alternatives. As Wigner pointed out, we never observe more than one out of several possible results of an observation. It is just a singular thing. So, how does the universe make its choice on which outcome will turn into reality? Since processes in imaginary time result in several events at the same real time, there's a necessity for a specific choice to be taken. Are we able to influence the choice? With our imagination, we are able to see possible results, and often we wish one specific result to become real. Each alternative gives a more or less different outcome. In some way, no alternative is real until a choice has been made. This is very good. In some way, no alternative is real until a choice has been made. Without the choice, there is no collapse. This is similar to imagination. We are able to imagine different futures. And then we decide which we wish to be real and act accordingly. So in some way we appear able to influence the possible firing of synapses in our brains, to fulfill our wishes. It cannot be excluded that the same kind of ability extends to external systems as well. Our own wave function is a part of the universal one. And before collapse, all possibilities are open. We might be able to wish a certain outcome to be chosen. There's a weak evidence that this may be the case. I'll make a summary there. This is in some ways extraordinary, important or crucial. I mentioned in the last part of 1387 that somewhere a decision is made, somehow, and that decision is the same as the coming event, the future. We speak about retrocausality. It's a bit of a handful of a word. It is not 100% correct from a quantum mechanical perspective. It is in between. Quantum mechanics' future is different. It is not linear. It is a definite part of the process. The next state, what happens after the collapse? Every new happening, every moment is an after the collapse. This is what next moment is. Our heritage of seeing happenings as things that come about from singular separable events put together that gives an outcome is shown to be incorrect in quantum mechanics. Both what happens and what doesn't happen are part and parcel of the superposition. As I stressed, all positions, all potentialities, the ones that doesn't happen and the ones that do happen. Normal thinking, classical thinking, thinks that things that has happened, and for that matter also particles, are what make up the next movement. Existences in relation to each other, and for some reason not non-existences. The imaginary time that has such an foundational property in quantum mechanics is, strictly speaking, unreal in ordinary common sense language, where the only thing that counts is the real outcomes. But it forgets or cannot see what is the aspect that make these factors become real. That is hidden. Emrian calls that emotion, wish. In constructive theory, that is another way of explaining the very same thing. It takes in consideration things chosen and things not chosen, and thereby covers everything. And that is what makes up a comprehensive explanation. On a down-to-earth level, would you say you have a choice if there are no options? No, you would not. A classical physicist could have said, the other options, they do not count, because you never made them. Well, the thing is, if there were no other options, there is no free will. So they do play a role. And it is even that classical physics cannot discern what choices are real, that could actually happen, and which ones cannot happen. Prematurely, they try to make that possible. We know the outcome. John Bell tried to prove that the superposition in some ways was decided by previous events. He proved himself wrong. That was reinforced by Clauser, and then later even more cleared out by Alain Aspect, another Alan. It is completely undecided, and this means the choices not taken are, strictly speaking, part of reality. The imaginary photons mentioned earlier by Emrian, they have a role to play, although they are not real. Imaginary time, that makes for another dimension to time, is non-existent, can never be true, but still it participates, and worst of all, it cannot clearly be discerned from real time. There is no way of doing that. I would say it doesn't even make sense to be extra hard. You cannot cut out the husk of unreality from the kernel of existence, real proper events. Emrian writes, this is similar to imagination. I would say that's absolutely spot on. it's imagination that makes for the new real. Not an imagination of a person within the classical world, but imagination itself, which has a deciding factor. And free will and this wonderful, wonderful, wonderful ability to make choice is something always self-reflective. I take good use of the Dutch master artist Escher, and I especially this time would like to take up the hand or hands, where one hand is drawing another hand. This is coming from M.C. Escher, The Graphic Work by Taschen, the German editor. Doesn't say when it was printed. Never mind.
The new printing is 2016.
2016, the new printing, the first one.
First one, I don't know.
That's the important one. Let's see here. I remember this one. The hands also have a very great part to play in the book by Douglas Hofstadter, Gödel, Escher, Bach. And as you can see here, and that is a big part of a point you can make from a painting or a drawing. You can make many points. This is not the only one. A word doesn't say as much as a picture. But one point which I would like to press now is it's impossible, very important, it's impossible to tell what is drawing and what is being drawn. And if you like it, signifier and signified. This is not a trivial word game. This is not semantics. This is what we know of reality. There's no way in the common sense Greek way of telling real events from non-real ones. And that means that everyone that tries to do that, even if he or she is a scientist, will do random choices. And they will randomly cut out a big portion of reality without even knowing which one they cut out. And they personally playing an impossible private language game will say those things are real and the other things are unreal. This is also another way, a second point from the drawing, of understanding the difference that, for instance, Jacques Derrida wants to point out between now and not now, present and not present. It's not a criticism of rationality. It's the salvation of being present and thinking. You will end up in the private language error if you try to do those impossible things. These hands are not impossible. This is how it works. This is a Klein bottle in hand, so to speak. Another thing I want to mention is, if you go the way of the classical formula, you will end up with existences all over the place. And then you get this consciousness as stipulated by David Chalmers. In my feeling, and this is my personal feeling here, this is not part of the lecture per se, that consciousness is an invention or a byproduct of having existences, essences, and so on. And it's passive, and we can never ever come to any conclusion what it is. It's a sort of an, like, it's like we're using the term object or the idea of objects' existences, and we turn it to ourselves, and we say consciousness is an res cogitans, if you like, some sort of object. No, definitely not an object. Has nothing in common with the misunderstanding that is object. It's the very process of wishing or having a choice. It's not the same thing. Maybe some question here or comment. Lighted.
Good evening. So last Thursday I discussed Söringens cat with Emre and also received comments from him. What surprised me is that Schrödinger's paper from 1935, it would have, I thought, and I think you also believed, it had an ironic purpose to show how ridiculous quantum physics was. That is, how can, so Schrödinger writes that the idea that the blurry thing that is like a blurry photo can represent reality, and I thought that was his argument against quantum physics. So Schrödinger said that a blurry photo without focus is not reality, so to say. So I thought he was ironic. He was there arguing against quantum physics. He was taking a step back from quantum physics. And then later on in 1943 and 1944 in Dublin, he embraced quantum physics fully. So the thing is, Allan wrote to me that Schrödinger did not argue against himself, so to say, in 1935. he argues against the natural thought that cat being alive and dead means that is in some kind of intermediate state, something like half dead. Okay, so let me rephrase it. So the idea that the cat is blurry, let's say that the cat is blurry in the box, and it's not like in a limbo, like a Dante's limbo. That I was thinking it was that the limbo is like kind of things that you see, like in desert. You see things in desert that is something blurry, like you see a cat that is a half-dead cat or a half-dead. And I also compared with in my mind with Penrose and the collaboration with what is the name of the collaborator of Penrose about consciousness. When you want to examine patients,
Stuart Hammeroff.
Stuart Hammeroff, thank you. Before an operation, you have to examine exactly what kind of consciousness they have. So there are different kinds of consciousness. Or if you put too much anesthesia, you can kill the patient. So it's very small levels. So you could say that. So I was thinking more that the cat. Okay, so you have the cat in the box. So Allan argues for a very strict. You have only 3 categories there in the box. So cat is only dead, or only living, or both at the same time. Like in the future computer, the quantum computers of the future, they have also only 3 states: 0, 1, and both at the same time. While I see things more in decrease, like when you put people to sleep before an operation, there are different kinds of mental consciousness, if you get my point. So I was taking blurriness in that sense, but perhaps I have misunderstood, so I want to have your feedback. Where is the truth, so to say?
Excuse me, I'm a little bit tired. As a PC, so I could do this.
I can help you.
Yes, yes. So.
So you can nod if I understood you correctly. You were previously thinking that the cat was in a half-dead state.
Like a wave, like a blurry, like a wave. If you think about a wave in, I don't know how to explain it.
Yeah, well, the most important thing, I'm not 100% sure.
Like a fog, if you have something like a fog behind a fog, so it's out of focus, like Schrödinger says, it's blurry. I was thinking that analogy.
Well, it's how can there's not even words to describe the cat in the superposition. Maybe blurry could work, yeah, but to think of it as a potentiality of being either dead or alive could give wrongful associations. It will be definitely one thing or the other afterwards, but it is strictly, and this is very strictly, absolutely non-decided before the collapse. Maybe, and I'm not sure, I have to read that reply from Allan Emreen. Maybe it was that Schrödinger wanted to make extra clear that the cat is not half dead or half unconscious or half living. That would be us still being sort of stuck in a 0 or 1 position and wanting to make a compromise. But the superposition is not a compromise. It's absolutely undecided. In the most absolutely undecided way you can ever think. You can even say it doesn't have properties like existence in any way whatsoever, but it will have absolute properties afterwards. This is how this is acting out. And what happened, this is my imagination playing out. Let me just speculate. I think that John Bell thought that some sort of state was before the collapse, that there was some properties, some compromise-like properties, that the cat was in some sort of becoming. Possibly similar to the pilot way of the Broly or Boom. It is very hard to give up that idea, and he was definitely fighting with it. Reading about the exploration of John Bell made that even clearer to me, that he thought with an F, fought with those things his whole life. Yeah, and I can also remember how I took it the first time I came about it. And I thought it was in a sort of half state or ghost state. I think that's actually quite natural and forgivable. I think that's the first understanding that one starts with. And later it becomes refined. And we get to this superposition, which is too stark in the beginning to accept, possibly. Yeah, this is my thing on the whole thing. Any more?
My objection would be that in real life you have different states, like in the hospital you have people who are half dying, and so you have different degrees. But in this famous box, the cat only has 3 absolute states. That's both Alans and the oppositions, as I understand, because we don't want any compromises. Do I understand you correctly? So no, we don't want any compromises.
Yeah.
Okay.
That is correct. So far correct, yes, I absolutely agree. It's a tough understanding to come to, but my opinion, that is what quantum mechanics tells us. And by that, I think we made a lot of progress. Thank you very much, and have a very pleasant afternoon.
Very
No,
excellent.
night.
Very excellent.